And welcome to another edition of 18 Minutes With, co-sponsored by the Kavli Prize. I'm Steve Mirsky with co-sponsor Scientific American Custom Media. For today's chat, we welcome Jane Liu, visiting professor at Boston University. She was a co-recipient of the 2012 Kavli Prize in Astrophysics for discovering the Kuiper Belt. We'll talk about that, and you can ask questions of Dr. Liu, which we'll get to in a bit. Dr. Liu, welcome.
Thanks. I'm glad to be here.
Just look on your screen if you're watching and look for how you can ask questions, if any come to mind. What is the Kuiper Belt, and how did you find out it was there?
Okay, the Kuiper Belt. It's a big donut-shaped belt starting beyond that starts roughly beyond Neptune, and it contains lots and lots of icy things like comet-sized bodies. Some of them are very big, like Pluto being probably the most famous and probably the biggest. That's the Kuiper Belt. How do we know it's there?
Yes, how did you find out it was there, and what were you actually looking for?
Well, the question that we set out to do when I was a graduate student was the question, is the outer solar system empty? At that point, we knew about the giant planets, and then beyond that, there was only this oddball planet Pluto, and that was it. We didn't know anything else. So we asked the question, is that it? Is that all the outer solar system? Is that all the content of the outer solar system? And we thought, well, maybe the answer is yes. Maybe that's all there was. But the answer could also be no. Maybe the outer solar system was full of things, but maybe they were too small and too faint to be seen. So we set out to answer that question: was the outer solar system empty? And either way, whether a yes answer or a no answer, either way, it would have been interesting. If it's a yes answer, that's fantastic. We discovered new things in the solar system. We can study them. If the answer is no, it's also a good thing to know. So that was the question we set out to answer. And during the course of gathering data to answer that question, we found the Kuiper Belt.
And how did you find it? What instrumentation did you use?
Our workhorse telescope was the University of Hawaii 2.2 meter telescope on Mauna Kea. And it's a medium-sized telescope. It wasn't big by any standard of those days, and it's considered even smaller by today's standard. But it was a fabulous telescope. It's on a great site, Mauna Kea, and we just used that to basically take deep pictures of the sky and see if we could find anything far away that would indicate, the outer solar system not being empty.
Now, the Kuiper Belt is named for Kuiper, who ironically predicted that there wouldn't be a Kuiper Belt.
That's true. So Kuiper in 1950 or 51 wrote a paper saying, well, he didn't think that the solar system stopped abruptly at the giant planets or Pluto, and he thought there might be a population of small bodies beyond the planets. But then he thought Pluto, for some reason, Pluto would have basically scattered all those little bodies away. So he predicted that they used to be there, and then Pluto just basically ejected them all. So he anti-predicted the Kuiper Belt, but the name kind of stuck.
Just for general point of information, is there any estimate of how many items there are in the Kuiper Belt?
Sure. So if to answer that question, you have to specify the size range that you're talking about. If you're talking about Pluto-sized bodies, probably a handful, maybe 5 or 10. But you're talking about, say, meter size, 10 meter size, there's probably billions of them. So it's a whole distribution. And the basic rule is, if you talk about big bodies, there's a handful of them. But if you're talking about smaller and smaller bodies, that population grows. So a handful of Pluto-sized objects then by the time you get to 10-meter size, it's probably like a billion. So it's a big population.
And what's the relationship between the Kuiper Belt and comets that we occasionally can see with the naked eye?
Well, the Kuiper Belt is one reservoir of comets. We know that comets are constantly being sent toward the inner solar system where we find them. And comets can come from two places. There are two reservoirs of comets that we know of. The Kuiper Belt is one of them, and the Oort cloud is the other. And we see comets coming in from both places.
And what is the Oort cloud?
The Oort cloud is another comet reservoir, but this one is extremely far away. It's basically at the edge of the influence of the sun. It's so far away that comets in the Oort cloud are easily stripped off from the solar system and just ejected into interstellar space. So the Oort cloud is another comet reservoir just at the extreme edge of the solar system. But that's it. Just another comet reservoir.
Do I remember correctly that if you go to the outer edge of the Oort cloud, it's about half the distance to the nearest star?
Yeah, it's basically, as I said, it's so far away that the sun's hold on these comets is very tenuous.
Mhm.
As you said, it's like halfway to the nearest star. So it doesn't take much to strip comets from the Oort cloud away from the solar system. Basically, it's just like the edge of the influence of the sun.
We do have some questions from some of our audience members.
Okay.
Let me ask you, what effects are the thousands of new low Earth orbiting satellites having on astronomical research? Do you have any views on regulation of those?
Oh, the effect is pretty horrible. If you take pictures of the sky, if you do astrophotography, or if you're an astronomer, if you take pictures of the sky, if your exposure time is longer than a few seconds, most likely you're going to see an artificial satellite streaking to your image. So it's worse than light pollution. for light pollution, you can try to get away from the cities, but for these satellites, there's just so many of them. There's really no escaping them, and it really is hurting the data that the astronomers want to take. And so I would very much like to have the artificial satellite population be regulated, but I don't know how that can be done. Usually, they paid for by rich people and rich corporations, and and those people usually seem to have the biggest say.
Mm-hmm. We've heard for a long time about maybe there's a ninth planet, although with Pluto's demotion, I guess it should be maybe there's an eighth planet. Father Guido Sarducci famously said, it's exactly like Earth, except they eat their corn on the cob this way. So do you have any views on whether or not there's a planet out there that we have not yet discovered?
I don't know, but I would not be surprised to find that the outer solar system still contain lots of things that we hadn't expected. The region that we have seen so far, which is basically from the sun out to a bit beyond Pluto, it is such a small volume of the entire solar system that it wouldn't surprise me at all. And in fact, I expect more things to be discovered in the outer solar system. But is it going to be big enough to be called a major planet? I don't know. And I think the evidence at this point is still inconclusive, so it can go one way or the other. So I can't say whether Planet 9 exists or not, but I can say I expect more things to be discovered in the outer solar system. Just whether they're going to be big enough to be planet-sized, that I can't say. But for sure, the outer solar system still contains lots of surprises for us.
Let's talk about Pluto for a second, because your work, you have a definite opinion about the status of Pluto based on your work.
Exactly.
An opinion that my 3-year-old nephew at the time, now he's in college, but when he was 3 years old, he was very upset about Pluto's devotion. But
what did you say? Well, what did you say to this?
I asked him, hey, how do you feel about Pluto not being a planet? And he said, I don't want to talk about it. But I know that among children, it was a lot of them felt a kinship to Pluto because it's so little, and they were sad about it being demoted. But your work, from a strictly scientific point of view, pointed to the correctness of its demotion.
Right. I mean, in terms of its origin and its evolution and its place in the solar system, it's just part of the Kuiper Belt. It's a big Kuiper Belt object, and maybe it's the biggest member of the Kuiper Belt, and it's a most famous one. But in terms of how it formed in the Kuiper Belt. It's very much part of the Kuiper Belt, and it evolved in that environment in the Kuiper Belt, like other objects in the Kuiper Belt. So it would be silly to pick out Pluto and say it's a planet where the other ones are not. Um, and I'm sorry that we upset your 3-year-old nephew, but um, but science doesn't care about the feelings of little children.
I think he probably knows that now since he's a chemical engineering major at Cornell.
And we don't want to hurt little children's feelings, but that's just the way it is. Science is what it is.
Here's a question from a viewer. What is your favorite science book? And then they quote from a book by Michio Kaku that says, perhaps the three-dimensional world we experience is just a shadow of the real world, which is actually 10 or 11 dimensional. We don't have to get into that string theory aspect of things, but what is your favorite science book? And do you have any opinion about what Kaku said?
Probably Dune is my favorite science book.
What
But
about straight science?
but I don't read that much science fiction.
Yeah.
So as a kid, I much prefer adventure stories. Those are much more exciting because, yeah, science fiction. It's too fantastical about things that I can't see on Earth. But adventure story, that's something else. You can easily imagine going on the ocean or on climb a mountain or something. Yeah, so science fiction, not too much, but adventure stories, that's much better.
So Robert Louis Stevenson, who was
That kind of stuff is
that kind of
it's
stuff?
so much better, I think.
So when you're in Hawaii at the top of the mountain, at the top of the volcano, freezing in
Yeah.
Hawaii, uh, did you feel like you were engaged in one of these adventures?
Yes, because we were looking for things that nobody had seen before. Maybe they didn't exist, but we were looking for them. So you felt very much like explorers, searching the unknown, and you were miserable. But you think that's all part of it. You were searching for the unknown in under miserable conditions, just like that's what explorers do.
Yeah.
So that was very much like that.
So the Kuiper Belt was discovered by you and your colleagues. It's approximately 30 years ago.
Mhm.
So what have you been devoting your energies to after the Kuiper Belt and after you were awarded the Kavli Prize 9 years ago?
After I spent some time in Arctic Norway teaching astronomy. That was fun. Um, and so the research I've been doing lately is, well, I would say the most exciting is the interstellar objects that came through our solar system. By now, we know of two. The first one came through 2017. That was Oumuamua,
Right.
and everybody heard about that one. And then 2 years after that, that was Comet Borisov. So two interstellar objects in 4 years. And I mean, they're tremendously exciting because, for a long time, people are curious about exoplanets. They want to know if we are the only uh, sentient beings in the universe. We build fancy telescope and send them to space, trying to look at exoplanets that might be Earth and all that. And so, but then with Oumuamua, then we suddenly realized, wait, I mean, another way to study these things is just to stay here and wait, and they will come to us. They're going to pass through our solar system and provide amazing opportunity to study them up close without ever having to leave Earth, which is rather nice. So anyway, so that's what we've been doing in the last few years.
And that object is probably not a spaceship from extraterrestrials. Although
I cannot disprove that.
there's
I
a
don't think
prominent
so, but
researcher
I
who
can't
has
disprove
put
it. I
forth
don't think
that
so.
idea.
I think there are other natural explanations that
Right.
might are more plausible.
The parsimonious explanation is not a spaceship.
Yeah,
We have,
not. I'm sorry.
no, we have a question from a viewer. Is the Kuiper Belt a mix of leftover material from the formation of the solar system, along with stuff from interstellar space, or do we know?
Um, well, we can't say that much about the flux of we can say something about the flux of interstellar objects based on Oumuamua and Borisov. Yes, so maybe out in the so the flux of interstellar object is significant, right? Because we see them and the their population is bigger than we expected. That's why we see 2 in 4 years. But so that's interstellar objects, and we don't know where they came from. We don't know how they formed, and so on. But about our own Kuiper Belt, yes, that the Kuiper Belt is just a byproduct of making planets. So if you have a star, and so and it seems that planets are byproducts of forming stars because planets we now know are common. So when you make a star, there's a good chance that you're also going to make planets. Planets are byproducts of star formation. And same with the Kuiper Belt. It's just leftover stuff that never got incorporated into big bodies. It's just small things just got left over. Planet formation is an inefficient process. That's it.
We just have a couple of minutes left. I just want to remind people that the Kavli Prize recognizes scientists for pioneering advances in astrophysics, nanoscience, and neuroscience. It's a partnership among the Norwegian Academy of Science and Letters, the Norwegian Ministry of Education and Research, and the US-based Kavli Foundation. Is there any thing you'd like to say about the effect the Kavli Prize had on your life, and whether you'd like to encourage other researchers to nominate their colleagues in the fields for which prizes are given?
Well, we did our work independent. When we did our work, we had never heard of Kavli prizes because they didn't exist at the point, and we did our work because we were interested in the question, and that's why we spent a lot of time doing what we did. But when we got the prize, it was extremely nice to realize that what we did was appreciated by our colleagues. We didn't expect that, and so when we found this out, it was a very nice feeling that we the hard work that we put into what all the years that was appreciated by people, and so that felt nice. And I think the Kavli Prize it's good to nominate people for the prize because there are people in science who tend to be quiet, and they're not in the news often. They just quietly do their work very dedicatedly and often very well, and then they're not fans, they're not directors of big corporations. They're just dedicated quiet workers, and it's nice for them to be recognized because they don't expect these things, and they're not in the newspapers being interviewed all the time. They just do great work because they're dedicated to what they do. And so nominating them for the Kavli Prize would just be a very nice way to recognize what they do, because they're kind of like unsung heroes. They just do their work fabulously well and very quietly usually.
We have another couple of questions from viewers. I can squeeze in one or two. Do you think we're going to find life in our solar system? Not what we would consider intelligent life, but any kind of living organisms somewhere in the solar system eventually?
I think there's a good chance. and because now we have find evidence of liquid water, not on the surface, but for a few satellites, particularly Enceladus, the satellite of Saturn, and Europa, the satellite of Jupiter. We know now there's a liquid ocean underneath the icy mantle, and there's a heat source, so that water is kept liquid instead of freezing. I it would be extremely interesting to just to probe that environment better, and it is difficult because this ocean is beneath the icy mantle, as I mentioned. But I don't think we can rule. We know about water-based life on Earth, but we really don't know about any other kind of life. So how can we rule things out? So, anyways, I think definite possibility.
Last question.
Okay.
And I was thinking about asking this, and you're too modest to give a real answer, but should the Kuiper Belt be renamed? Because after all, Kuiper said it wouldn't be there.
Exactly.
And if we renamed it, it should be the Lou and colleagues belt, probably.
No, we weren't even the first. Well, Kuiper predicted it and anti-predicted it, but there was an Irish astronomer named Edgeworth who came up with the idea too about the same time as Kuiper, and he didn't anti-predict it. He predicted it, and he said, okay, that those these icy bodies should still be there. So if anything, it should be called the Edgeworth Belt. But I think that at this point, the public it's so fed up with astronomers changing things on them. Regarding the outer solar system, they've had enough. That Pluto is now demoted. It's no longer a planet. It's now a dwarf planet of all things. And now you're going to go tell them, no, the Kuiper Belt is not a Kuiper Belt. Now it's the Edgeworth Belt, or whatever you want to call it. I think we just best just leave things alone at this point.
For now, anyway. I think it might be the Lou Belt someday. Dr. Jane Liu, it was such a pleasure to talk to you today. Thank you so much.
Thanks for talking to me. It was fun.
See you next month, everybody.
Bye, everyone.